Hello and welcome to Robert's Tech. Today on this video we're going to be talking about our programmable speed control. This is a board that we designed for robot rover projects. It's a dual motor driver. You can drive 3 amps each motor, and the unique thing about this motor driver is that it's programmable. It has an onboard Arduino Pro Mini in this version, and in this one an onboard SAM-D21 processor. What this allows you to do is program your own speed control code any way you want it to work. Has serial port connection for communicating your commands to it, or it has inputs for directly driving the speed and direction. The inputs will actually accept an analog 0 to 5 volt or 0 to 3.3 volt depending on which processor you're using. Or it will actually accept a pulse width modulation input, so you can drive it directly from an Arduino Uno. So when you use the analog output drive from the Arduino, which puts out a PWM signal, you can drive that straight into our controller and it will automatically convert it into a speed. It has 2 inputs for wheel speed sensors, and it can use a proximity detector like this, which configured next to a speed star system like we sell. This gives you a pulse as the tire rotates, and that goes into the input, and you can pick that up and measure the speed. The board includes 2 inputs for sensing your wheel speed. These inputs can be used for proximity detectors such as this one, a Hall effect sensor, or optical sensors. So with those 2 inputs, the processor watches those and can calculate the speed of the wheels, and then you can use that to regulate the output from the motor drivers. The board is fully protected input and output with fuses. These are self-reset fuses, so if you do have a temporary overload, it will reset on its own and go right back to running. The drivers used on this board are fully protected for thermal overload, overcurrent. You don't have to worry about overloading the board at all. The board also includes potentiometers, so you can make adjustments to different parameters. It's set up for a gain, a peak gain, and a local speed, and allows you to make fine-tune adjustments to get everything operating the way you want. With this thing in full speed control mode, your robot is able to do any type of motion, forward, reverse, and straight lines, curves, and any way you want to program it, and it can do it accurately. There are 2 options for the processor on this board. This is an Arduino Pro Mini, and this one is a SparkFun board, a SAM-D21, and both plug right in, and you simply put in 5 volts for the Arduino Pro Mini and 3.3 volts for the SAM-D. And the SAM-D is a much higher frequency processor, allowing you to do very precise speed control. With the Arduino Pro Mini, you can do basic motor control. There's also a brake input, which completely bypasses the processor. These motor drivers have built-in braking, so you just have to have a digital signal to control that. That allows you to put the brakes on the wheels without having that happen locally. It can be done from remotely, so that anytime you need to stop the unit, you can just send a stop command and it'll just stop. And it doesn't matter what the processor, the local processor, is doing at that moment. There's also the option of auto braking. If you write the code that way, you've got a jumper here to select that, so that anytime the speed goes down below a certain amount, it will automatically brake the wheels. There's a fan output that you can use if you're really in a really tough environment where you're driving this thing at its limits all the time and it may get a little too hot. There is a thermal output here for a fan, and that's totally independent of the processor. So here we have a very popular motor driver a lot of people use for their first robot rover project. Very inexpensive. It uses the L298 chip, which has been around a long time. It's not really comparable to something like this, our motor driver speed controller board, but I just want to give you a little idea of why you might want to use ours over this one. This one is very inexpensive, so it's a good choice if you're on a tight budget. Ours is more money, but it actually will drive more power, and I think what you'll find is that depending on how big your robot rover is, sometimes it's hard to keep them going straight if you don't have enough power to drive the wheels. You won't have any problem with this one. It puts out plenty of power for your medium to small size robot rover, and just that alone, that one feature alone, is really going to help you to build a better robot rover. This one I think is rated at 2 amps. Ours is rated at 3 amps on each driver. This uses bipolar transistors, and this uses FETs. The difference there is that you will get quite a bit of voltage drop with the bipolar transistors, and that in itself causes more lag in the drive of the motor itself. You won't get quite as much power out of it. With the FETs, you have very low voltage drop, so more of the voltage that's available will go to the motors, and you'll get a much better response out of the motors with an FET driver than you would with a bipolar transistor driver. Our board also includes speed control. Of course, that's where it parts from this a lot. This doesn't have any speed control built in. Ours allows you to program speed control into the assembly because it has an onboard processor that you can use to do that as inputs for the speed sensors. So that can be done externally with another processor. If you pair this up with an Arduino, that can be done that way. But again, you're looking at a motor driver that really is only meant for very small, lightweight robot rovers. So if you're getting into a heavier one, such as the one that we have here, like we've been showing on some of our videos, there's no way this can be driven with something this small, so you have to get up to the next size. Everything on the board is top quality. All the parts are sourced right here in the United States. The board is built in the USA, so it's all through-hole components, and it's easy to repair the board if you have to. So our speed control boards are available on our website, roberts.tech, as well as other products for your robot rover project. Thank you for watching this video, and we'll see you on the next video.